Hello everyone. Today we are going to learn about three-phase circuit. Welcome to the session on three-phase circuit. In this lecture, we will understand what is single-phase, two-phase, and three-phase systems are, why three-phase systems are widely used, how three-phase voltages are generated in practice. Let us start with the basic idea of a phase. In AC system, a phase refers to how the voltage or current waveforms are shifted in time with respect to each other. When two waveforms reach their peak at different instants, we say that there is a phase difference between them. It is measured in degrees. Single phase system. The generator, motor, transformer or rectifier has only one winding. This means there is only one alternating voltage, so all the power is carried by a single sinusoidal waveform. Single phase is common in homes for lighting and small appliances, but has limitation for higher power applications. A two-phase system uses two windings. The voltage or current in these two windings differ in phase by 90 degrees. Historically, two-phase systems were used, but today they are rare because three-phase systems are more efficient, convenient for power generation and distribution. Three-phase system. In a three-phase system, there are three windings. The voltages or current differ in phase by 120 degrees from each other. This arrangement gives three sinusoidal voltages each shifted by 120 degrees, forming that we call a three-phase system, which is standard for modern power system. And then polyphase system. When there are more than three windings with a specific phase between them, we can call the system a polyphase system. Among all polyphase systems, three-phase system is most popular because it gives a very good balance between performance, simplicity, and cost. Advantages of three-phase system. Three-phase system has several important advantages over single-phase system. First, they are more efficient for transforming the same amount of power over the same distance with the same power loss. Second, for a given power rating, three-phase machines and equipment are smaller in size and generally cheaper compared to their single-phase equivalents. In transmission lines, the three-phase system requires less conductor material than the single-phase system for the same power and loss. Three-phase motors produce almost uniform torque, whereas single-phase motors produce pulsating torque, which can cause vibration and less smooth operation. More benefits in practice. When three-phase generators are connected in parallel, they do not produce certain type of harmonics that can be cause distortion and heating problems. Also, three-phase motors are self-starting, which means they can start their own when supplied with three-phase power, while most single-phase motors need additional starting arrangements. Faraday's law and single-phase generation. To understand how AC generated, recall Faraday's law of electromagnetic induction. Three things are essential to produce electric current by induction: a magnetic field, a conductor, and relative motion between the conductor and the magnetic field. When the conductor cuts the magnetic flux lines, a voltage is induced in the conductor, and the magnetic magnitude and direction of voltage depends on speed and direction of motion. Imagine a single conductor rotating in a magnetic field between North Pole and South Pole. When the motion of the conductor is parallel to the magnetic flux, no flux cut and therefore no voltage is induced. As the conductor rotates, makes an angle with the flux, the induced voltages increases. When the conductor moves at 45 degrees of 30 degrees to the flux, as you can see the diagram, the conductor is moved. The induced voltage is about 0.707 of its maximum value. When the motion is perpendicular to the flux, the conductor cuts the maximum number of flux lines per second and the induced voltage reaches its maximum. As the conductor continues to rotate back towards a parallel position, the induced voltage decreases again to zero. So in this diagram, it is in the 45 degree of motion. And then now it is in the perpendicular position. So the sine waveform is reaches the maximum value. As you can see that it is again rotated. It is comes near to the zero. As the conductor completes half rotation, the direction of motion relative to the magnetic field reverses. So the direction of induced voltage and currents also reverses. This continuous change in magnitude and direction of the induced voltage with rotation produces an alternating voltage waveform or AC over each full cycle. As you can see that again the conductor move towards a opposite direction. Okay, so it is completed one rotation, so we'll get the sine waveform. Now instead of just one conductor or one coil, consider three separate coils placed in the stator of a generator. If these three coils are arranged 120 degree apart, each coil will see the rotating magnetic field at different position in time, and therefore each will generate its own AC voltage shifted by 120 degree from each other. A typical three-phase generator has rotating magnet called the rotor and a stationary set of windings called stator. On the stator, three separate windings or coils are placed with terminals labeled A, A', B, B', C, C'. These windings are physically spaced 120 degree apart around the stator inner surface. As the rotor spins, the magnetic field cuts across the three-phase stator winding because of 120 degree physical separation. Each winding experiences changing flux at a different time, so that induced voltage three windings have equal magnitude but are phase shifted by 120 electrical degree from each other. If you plot three-phase voltages from the three-phase generator on the same graph, we get three sine waves. Phase 1 often taking as a reference, phase 2 lags phase 1 by 120 degree and phase 3 lags phase 1 by 240 degree. Equivalently, phase 2 leads phase 3 by 120 degree and phase 1 leads phase 3 by 240 degree. This 120 degree separation is what gives three-phase system their special advantages. At any instant, the sum of three-phase voltages or currents balanced system is zero, which leads to smoother power transfer, reduced vibration in machines, and better utilization of material in cables and equipments. To summarize, the three-phase system consists of three AC voltages of equal magnitude separated by 120 degree in phase compared to single-phase system. Three-phase systems are more efficient, use less conductor material, produce uniform torque in motors, and are the backbone of modern power generation, transmission, and distribution. Thank you.